Now that we've talked about basically everything when it comes to energy and electricity, um, remember at the beginning of the unit we talked about different types of energy, and we discussed how there's mechanical energy, thermal energy, there's nuclear energy, I'm trying to think here. Oh my goodness, what am I missing here? Chemical energy, electrical energy. And then we talked about how electricity is a form of energy, but not all energy is electricity. So we can't just say that all energy is electricity. That's not true, which is why we talked about the different forms. So today, we're just going to review some of the concepts that we've talked about. And then we're going to talk about the efficiency of energy. So, first we have this statement, and I believe I've mentioned it a few times in class, but energy cannot be created nor destroyed, but is transformed in any other form of energy. So, basically, what we've talked about before is remember when we said how matter cannot be created nor destroyed? We can break it down, we can build it up, so we can change what it looks like, but it just can't be, like, it just doesn't disappear. So that's the same as energy. So energy just can't disappear. So you can't create it or destroy it. It just exists, but it can be transformed. So energy can be transformed, and we can transform it into any other form of energy. So we know that when we do so, we can also have a loss in the form of other types of energy. So, for example, if you want to go for a run, before you go for a run, you want to make sure that you have enough energy in you. Well, we have chemical energy in us, right? So we eat, we have enough fluids in us, electrolytes. So those are all our chemical, that's our chemical energy. Now, our chemical energy will then transform when I run into movement or mechanical energy. Now, that's what I want to get out of running. What I don't want, but happens anyways, is that we end up getting some heat energy. And so remember when we said that we lose energy in the form of heat? So that's exactly what happens, is that we lose energy in the form of heat. So we get really hot, so we sweat. So that is just a form of lost energy. Okay. Same with a flashlight. So we have chemical energy because it's the battery or the cell, I should say, that is in the flashlight that helps us light it up. And what we really want is light energy. So we really want light energy. But sometimes, like we talked about with our cell phones, the appliance gets hot. So our flashlight will get hot. So that's just an indicator that we're losing losing energy in the form of heat. So we're going to talk about efficiency. So that means that energy transformations are inefficient. They're not 100%. So the law of conservation of energy states that energy cannot be created nor destroyed, only converted to other forms. And when we convert it, we usually lose some energy. So the input energy is always bigger than, so greater than the output energy. So what does that mean? Well, that means if my lamp can only provide me with 500 joules of power, well, I'm only going to get 300 joules out of it. I can't get 700 out of 500. That doesn't make sense. I can't get more out of it than what it gives, but I can take anything less than it. Will I ever take equal to it? Well, no, because nothing's perfect. And then we also talked about different types of energy and is most commonly lost in different forms. So the three that we're going to talk about, or the most common one, is heat. Then we have sound, and we also have light. So those are three different forms of energy that energy can be lost in that form. Usually we're going to talk about heat. Now, we're going to use a specific formula to help us calculate efficiency. You're going to see this formula from now till probably when you're done school. And you'll probably see it eventually after school. But it looks different in most cases, but we're just trying to find a percentage of efficiency. Similar to when you want to find the test mark on a test. So if a test is out of 20 and you got 15 right, well, to figure out the percentage, you would times that by 100. Sorry, divide them times by 100 and get your percentage. So same idea for efficiency. So we're going to use this formula. So useful energy output over useful energy input times 100. And output and input, I'll explain them more in depth. So we're going to do two different questions. And these questions are similar to what you're going to see on your worksheet. So I put the formula up here just so we can have it. So we have an incandescent light bulb uses 780 joules of energy to produce 31 joules of light. So very inefficient, right? If you're only getting 31 joules out of the 780, inefficient. What is the efficiency of the light bulb? So what we are going to do is we are going to plug in what we know. Well, for our input and output, obviously the question doesn't say input and output, but I know that I have 780 joules of energy and we only end up really using 31 joules. So when we use this formula, the amount in total of what the appliance can provide is going to go on the bottom. So that's 780 joules. And how much useful energy did we get out of it? Well, we got 31 joules of useful energy. So it's 31, command you, 31 over 780, and we're going to times that by 100. So again, another way I usually teach it is my big number goes on the bottom, small number goes on the top, and then we can just plug it into our calculator. So how you would plug this into your calculator is you would go 31 divided by 780, and then you're going to get a decimal. So I'll actually just write it on the side here. So I'm going to get a decimal, and that decimal is going to be 0.039. I'm just going to round it there, and then I'm going to times that by 100. And when I times that by 100, I'm going to get 3.9%. So that means this light bulb has a 3.9% efficiency. Very inefficient. You can tell by that. So that's how I use the formula here. Okay? That's as easy as it gets. You will have some more complex questions. So a printer that is 56% efficient. Now I have the efficiency percentage, okay? So it's 56% efficient, consumes 300 kilowatts of energy. How much useful energy did it provide? So I want to find my useful energy that it could provide. So again, we're going to use this formula, but this time we have different things we plug in. So I already know my percent efficiency. It's 56% efficient. Okay. I don't know my useful because it wants me to find my useful. So I'm actually just going to make this my x. So I'm going to find my x here. And then what is the amount of energy that it could provide? Well, it could provide up to 300 kilowatts of energy. And we usually times that by 100. So I'm just actually going to change this from y to y. So then you guys don't get confused between x and y. And then, so there we are. Okay. So we are going to use this now to help us find y. So we're going to do opposite operations like we always have done. So we're going to start with the 100 first. I want to get y by itself. What's the opposite of timesing 100? Well, it's dividing 100. And what I do to one side, I must do to the other side. So I'm going to divide by 100. So what I do to one side, I do to the other side. Okay, remember these are opposites. So 100 divided by 100 is just going to equal to 1. So I will just do this because I know you guys like it when I do that. So it's equal to 1. Now I'm left with 56 divided by 100. So I know that that is equal to, remember we moved the decimal place over twice. And now I'm left with Actually, sorry guys, 300. Now this is gone. Okay, let's actually move this closer. There we are. So now I'm left with 0.56 times or equals y over 300. Y is still not by itself. I still need to get y by itself. Well, what's the opposite of dividing 300? I'm going to multiply by 300. What I do to one side, I get to do to the other side. So 300, again, we're isolating for my variable, times by 300. Well, 300 divided by 300 is just 1, so I'm just left with 1y. And now I have to multiply 300 by 0.56. So 300 times 0.56 is 168. So finally, I get an answer of y equals 168. Let's make sure we have units. We were measuring in kilowatt hour, so we're going to leave it as kilowatt hour. Okay, and that is my answer. So you guys will have a worksheet to complete, and that is all.